In this video, we're going to introduce our electrochemistry unit, which is also known as the redox unit. We're going to be going over some basic terms such as reduction and oxidation, reducing agents, and oxidizing agents. So electrochemistry, that is going to be the study of electron transfers in chemical reactions. So electrochemistry is often referred to as redox since all electrochemical reactions are composed of two parts, reduction and oxidation. So what are these two parts? Reduction is the process in which a substance is gaining electrons. So I'm going to abbreviate electrons to E with a little negative sign. Now, oxidation is going to be the opposite. It's a process that involves a substance losing electrons. Okay, so it's very important that you understand that reduction is where electrons are gained and oxidation is where electrons are going to be lost. So these are two terms that you're going to want to know. Okay, now reduction, as we said, it's when an atom or an ion is going to be gaining an electron. That is what we call reduction. So some examples here of reduction, we have copper 2+, and it gains 2 electrons to become copper solid. Okay, so it's important that you understand when you're reading half reactions such as this, that if you see electrons on the reactant side, they're being gained. So because we see electrons on the reactant side for both of these half reactions, that's going to tell you, okay, both of these are reduction half reactions. Okay. Now, reducing agents, that is the ingredient added that causes the reduction of a metal compound into a pure metal. So just looking over here, talking about reducing. So historically, reduction, it's meant to make a metal from a compound, which in this case would have been an ore. Okay, so that's what reduction is meant, and so that's why we say that reducing agents are the ingredient that you add that causes the reduction of a metal to make a pure metal out of that ore. Okay, so that's historically what it meant. For oxidation, historically what it meant was you have a metal reacting with oxygen to create some sort of compound. So sometimes it would be rust that got formed. Okay, so you don't need to know the historical definitions or the historical uses of reduction and oxidation processes. That's just a little fun fact there. Okay, but what you should know is you should know what reduction and oxidation, what those processes are. You should also know what reducing agents are. Typically, they get shortened to RAs. So just be aware that's going to be my shorthand for reducing agents is just RA. Okay, now oxidation, Again, this is a term that you're going to want to know. It's just when a substance, atom, or ion loses electrons. That's what's called oxidation. So some examples here, we have copper solid undergoes oxidation and produces copper 2 plus as an ion and 2 electrons. Okay, so notice in both of these oxidation half reactions, the electrons are on the product side. That means that those electrons are being lost from your starting substance. So that's what you're going to look for to tell you when a reaction is an oxidation reaction. You're going to look for the electrons being on the product side. So when electrons are on the product side, that means electrons are being lost. Now, an oxidizing agent, that's the ingredient that causes the metal to become oxidized. So it makes a metal into an ion. Okay, so keep in mind this is the empirical definition of an oxidizing agent, which oftentimes I do shorten to OA, so just be mindful of that shorthand. That's what it means. Okay, but further into this lesson, we'll get into what actually happens to these oxidizing agents, because the trick here is with reducing and oxidizing agents. Reducing agents cause something else to be reduced. Oxidizing agents cause something else to be oxidized. So that's very important. Okay, so to memorize these processes of oxidation and reduction, there is a memory device or a memory trick that's called Leo the Lion Goes Grr. And we'll capitalize there. Okay, so for Leo, what that stands for is losing electrons is oxidation, and Grr means gaining electrons is reduction. Okay, so some other teachers might use oil rig, and it means the same thing. So this is oxidation is loss of electrons, and then rig is reduction is gain of electrons. Okay, so I typically end up using Leo the Lion Goes Grr, but if you like oil rig better, you can use that so long as you remember oil stands for oxidation is loss of electrons, and rig is reduction is gain of electrons. Okay, so with oxidation and reduction, what happens to your substance with oxidation is your substance is going to become more positive. Okay, that's what happens in oxidation. And the reason why that happens is because you are losing electrons. Now, in reduction, your substance is going to become more negative. And the reason for that is because you're gaining electrons. And remember, electrons have a negative charge, so the more electrons you gain, the more negative a charge you have. Right? So that's why reduction, if a substance undergoes reduction, it's going to become more negative. Okay? Whereas for oxidation, it becomes more positive because it's losing electrons. It's losing that negative. For writing half reactions, you got to remember that every redox reaction is going to contain both a reduction half and an oxidation half. So the combination of reduction and oxidation, the first couple of letters from both words, that's where we get the word redox. Okay? So every redox reaction has a reduction half and an oxidation half. When half reactions are written separately, the electrons are written in the half reaction equation. Now, when electrons are lost, which happens in oxidation, they are written on the right side of the equation. So they're written as a product. And when electrons are gained, which happens in reduction, they are written on the left side of the equation, so they are a reactant. Okay, so you should know for half reactions, whether they're reduction half reactions or oxidation half reactions, you should be writing your electrons in each of these half reactions when you do write them. Okay? And what differentiates the two of them is that oxidation, since electrons are lost, they're going to be on the product side. For reduction, since electrons are gained, they're going to be on the reactant side. Okay, so this is just some practice problems right here, but I'm going to move on to the next part of the notes. Okay, so let's get into converting a net ionic reaction into two half reactions. Okay, so a reduction half reaction and an oxidation half reaction. How we're going to do that is we're going to break the net ionic reaction into the two half reactions, but we're going to leave out the coefficients. We're going to balance the substance by putting a coefficient out in front. We're going to make sure to balance the electrons. How we're going to do that is we're going to add electrons to the most positive sides, and our goal is that both sides are going to have the same charge. And then last but not least, we need to label each half reaction as either reduction or oxidation. And how we're going to figure that out is by looking and seeing, okay, are our electrons on the product side or the reactant side? All right, so for this first example, how we take this net ionic equation, which is given to us, and let's label that here. This is what a net ionic equation looks like. So this is just my shorthand for equation, EQT. So what you're going to do is you're just going to play a game of what looks similar. Okay, so I'm looking here, and I've got a niobium 5+ ion. So now that I've located that on the reactant side, I'm going to look at the product side and say, okay, what looks similar to that? Well, that's the niobium 3+ ion. Okay, so I'm going to use those two substances or those two ions to create my first half reaction. So I'm going to go niobium 5+ aqueous. I'm going to leave a little space, and then niobium 3+ aqueous. Okay. So now what we're going to do, I'm just going to work on one half reaction at a time. So I've taken out one half of the reactions from the net ionic equation so far. Now I'm going to look and I'm going to say, okay, the reactant side has a total charge of 5+, whereas the product side has a total charge of 3+. So we need to add our electrons to the more positive side so that each side has the same charge. So what I'm going to do is I'm going to add 2 electrons to the reactant side, because if I go 5 minus 2 from the electrons, right, that'll give me 3 plus, which means the reactant and product sides both have the same charges. Okay. So looking at this, we have our electrons on the reactant side, so that means electrons are being gained, and then Leo, the line goes gaining electrons is reduction. So this will be reduction. All right, so let's look at our other equation here. So we've got titanium 3 plus, titanium 4 plus. We got those two ions, so let's use those. So titanium 3 plus goes to titanium 4 plus. Now, there are coefficients of 2 in front of both of them, okay? But remember, for step 1, we're going to leave out the coefficients here, okay? So, looking at the charges of each side now. So, I've got a 3 plus charge on my reactant side, and I've got a 4 plus charge on my product side. So, we're going to go to the more positive side, and we're going to add our electrons there. So, I only need to add 1 electron to bring that down to 3 plus. So, now both the reactant and product side have the same overall charge. So that's done. Now, since I have an electron on the product side, that means that the electrons are being lost. And if we recall, Leo, the line goes grr. Leo, losing electrons is oxidation. Okay. Okay. And for where we are in this course right now, that's where we're going to leave the half reactions, okay? But later on in the course, we will do more with the half reactions in order to balance it. And I'll show you later on in the course how we're getting these coefficients. Okay, so which substance is undergoing reduction? So that's basically just asking, okay, which substance is gaining those electrons? Well, niobium 5 plus gained those 2 electrons here. So that's what I'm going to say. And you know what I didn't write? I didn't write my states here, so let's add that in. Okay, so always remember your states. Always write states when you're writing chemical reactions here. Now, we're asked which substance is undergoing oxidation. So which substance lost these electrons? Well, titanium 3 plus lost those electrons to become titanium 4 plus. Okay, so we see that titanium 3 plus got more positive as it lost those electrons. So that's how we know. Okay, moving on to the next question here. So again, we're going to play this game of what looks similar on both sides. So phosphorus and the phosphide ions, those look similar. Okay, so again, we're just leaving the coefficients right now. Okay, so whenever you have an element by itself, its charge is going to be 0. So the overall charge of the reactant side for this half reaction is going to be 0. For the product side, it's 3 minus or minus 3. Okay, so once again, I'm going to the more positive side, which is the reactant side, and I need to add 3 electrons in order to get it to that -3 or 3 minus, however you want to say it. Okay, For the other half reaction, we're going to be looking at our iodide ion turning into iodine. So that's going to be iodide, aqueous, and then iodine. Okay, so for our charges here, we have -1, and then here we have an element on our product side, so that charge is 0. So we're going to our more positive side, and we're adding electrons. Okay, so now both sides have a -1 charge. All right, so let's label these. For our first one, we have electrons on the reactant side. That means they're being gained. So that means reduction. And then for the other reaction, our electrons are on the product side, so those electrons are being lost, so it's going to be oxidation. Okay, so remember, every redox reaction has reduction and oxidation happening at the same time. Okay, so which substance is undergoing reduction? Well, that would be phosphorus, because that is what is gaining those 3 electrons. So P4, solid. So remember, if you're wondering why it's P4 and not just the letter P for phosphorus, you got to remember that phosphorus is a polyatomic element, so whenever it's by itself, there's 4 of them all together. All right, now which substance is undergoing oxidation? Oh, that went away. Well, let's fix that. Oxidation. Okay, so the substance that is losing electrons is going to be our iodide ion. Okay, so super important, and I've mentioned this before, oxidation and reduction must always take place at the same time. So these reactions have become known as redox reactions. Okay, so what's happening in redox reactions is with oxidation, electrons are being lost. Now in the reduction part of a redox reaction, those same electrons that are being lost in oxidation are being gained by a different substance that's undergoing reduction. So when one species loses electrons, another species, so by species I mean chemical species or chemical substance, gains those same electrons. Okay, so here's just some more practice problems. Let's move on to the next part of the notes, oxidizing and reducing agents. Okay, so oxidizing and reducing agents, they can be a bit tricky. So as a reminder, my shorthand for reducing agent is Ra. So reducing agents, they cause other things to be reduced, but they themselves are oxidized. That's what's so confusing about reducing agents and oxidizing agents is you would think, oh, it's a reducing agent, it should be reduced. No, it causes something else to be reduced, and in the process, it itself undergoes oxidation. Okay, so that's very important to know. Reducing agents are undergoing oxidation when they cause something else to be reduced. Okay, and the oxidizing agent is going to be reduced. So reminder, oxidizing agent, if I say OA, it means oxidizing agent. Okay, so something you can use to help you remember what happens with reducing agents or oxidizing agents is you could think of a travel agent. Okay, so a travel agent helps you to plan your vacation, but they themselves don't go on vacation with you. Same thing with reducing and oxidizing agents. So a reducing agent helps something else to be reduced, but it itself undergoes oxidation. An oxidizing agent helps something else to get oxidized, but it itself gets reduced in the process. Okay? So very important that you know what each of these do. Okay? So if you want to make yourself a little chart to summarize all of this, this is what I would recommend that chart be. So we've got our agent, type of reaction, which I'm going to abbreviate to RXN, gain or lose electrons, and then the last one, how the agent is changed, I should say. Okay, so if we have, let's finish this here. Okay, so if we have an oxidizing agent, it's going to undergo reduction, which means the oxidizing agent, if it's being reduced, it gains electrons. Okay, so what that means is that oxidizing agent is going to become more negative. Because if you gain electrons, you're gaining more negative charges. So that's why you become more negative. For a reducing agent, it itself undergoes oxidation when it helps something else to be reduced. Okay, so if it's undergoing oxidation, that means it's losing electrons or loses electrons. So that means if it's losing its electrons, it's going to become more positive. Okay, so with reducing agents and oxidation agents, you can use this little table just to help you out, especially in the beginning with the practice questions here, but also just remember to think about the travel agent. The travel agent helps you to go traveling, but they themselves don't go traveling with you. Okay, same with oxidizing and reducing agents. Reducing agents help something else to get reduced while it itself undergoes oxidation. Oxidizing agents help something else to be oxidized while it itself gets reduced. I'm repeating this quite a lot because it is easily confused by students.